We have a question right here.
All right.
Hi, Kent McMullen from DigiCert. I think this is probably for Chris. How do you secure the polls?
That is a great question. So first of all, there's an aspect of physical security because you have to get on a bucket truck to get to it. But I have to admit that one of the topics here throughout the whole conference is if you have these devices that are distributed outside, security is a big problem. And so working with a number of the cybersecurity companies to figure out, particularly on the operational technology side, how you secure those things. So I don't really have a good answer for you. I will say, though, that our streetlight controllers, we communicate over the smart grid networks from Cisco and Itron and some of the other low-powered wide area network guys that have really good security from the access point back. But I have to admit readily that this is a problem that the industry needs to work on. Anybody else have any comments on that? I mean, Jim, what do you think? It's tough, right? Yeah. I mean, our friends at GE, we deal with this because you're going to have this heterogeneous mix of stuff, right? And so the internet suite that Amazon Web Services has built-in security, so we're just learning about that. But great question.
Sure. Yeah, please.
So we're using the OpenWay Riva network, and the secure, so that it is an intelligent device that you could put apps on, but the comms or the security is all, we can't touch the security. So the security is native to the meter network, and it's pretty strong security. So the meter itself is, the application side is separated really from the network security side of things. And as we've been playing and developing, we got used to turning ports on and off, and then found out that, oh, well, we really don't get to do that because that's all locked down from a security perspective.
Yeah, that was one reason we've actually chosen to implement streetlight controls on those networks, Cisco, Itron, Ingenuity is another one, because they are quite secure, and we are certified on those networks. But you can be hacked. There's an example on the internet where there's a building that has lighting inside that's running on a Zigbee network, and a drone flies by and it hacks it. You might want to look it up. I won't tell you who the lighting company is because that's not fair, but and it's not GE. But it's a problem, right? And I think we as an industry, both on the industrial side and the process control side, as things go outdoors and more wireless, it's something we've got to figure out together.
Yes, I would agree with that. I think there's still a big challenge there, in which when you talk about smart cities.
Yeah, we'll pass you the mic so everybody can hear you.
Just 1 second. There was one question.
This is for Kurt. Kurt, correct? Yeah. I'm Sid Snitkin with ARC. I lead the cybersecurity stuff at ARC. I don't want to talk, it's not a cybersecurity question per se, but it was I'm confused about the networking. I mean, the platform and networking for all of this in smart cities is a big issue. I understand that. And you made a comment about the meters. I'm big into meters and the way of using meters as gateways and things like that and connectivity. And you mentioned there was a mesh network. And I don't know if that was only for the microgrid applications or there were other use cases you mentioned. And I'm a little confused. Is that the primary net? So are you trying to provide a platform for the city, in a sense, for smart city IoT or whatever terminology you might be using? Or was that only for the grid, the microgrid?
Yeah, okay, so the meter network is a multitude of networks. So the mesh itself that's meter to meter, peer to peer is typically 900 megahertz radio, but they all go through what they call a CGR, which then is Wi-Fi. And so it depends on what our use cases are, which network we're going to use. So our distribution management system actually leverages the Wi-Fi, because that's a SCADA type network, so we're taking, every 5 seconds we're getting data back on that network. I think the way to think about it is you hear a lot about all this data we're going to stream, and it really, and big data, and it annoys the heck out of me because I don't want more data. I actually want less data. I want outcomes. I want things to be decided and for the information to come in saying something happened and this is what it is. You need to take action, but so that's where the meter network and having that intelligence at the edge, we're trying to drive to actual statements of fact that is derived from the data that's on that meter. So anything that we can do in that realm will fit that network really well. And we are streaming the data from those air quality sensors without any issues, but that is, going just one span up into the CGR, and then so it's not really saturating that lower network. So it really gets to the use case, the data that's required as to which network we're going to actually leverage. But it all needs to talk. The key thing is it's peer-to-peer. So I need that device that's on the Wi-Fi network to be able to talk to the meter, because the meter might be actually telling the switch to operate because of what's happening at the lower level.
I could add a little more commentary. The one reason we developed streetlight controls that run on Itron and Cisco and others is that these are mesh networks. They're peer-to-peer. They talk to each other, and then they talk to an access point with either cellular or Wi-Fi or fiber backhaul. So if you have like in the Urbanova district, if you have their Itron meters deployed, we can put in streetlight controllers. They actually strengthen the network because you now have more nodes out there, and it reduces the number of hops and the distance that have to travel, and it gives you more capacity. And from a city and utilities perspective, they don't want to have to support multiple networks. So if you look at meters, you look at streetlights, they don't generate a lot of data, and it's not communicated that often unless there's an outage or some anomaly. So it's a really great way to do it. It's the ultimate outdoor application of Metcalfe's law. Make sense?
Thanks. And we had some comments here. If you don't mind just telling us who you are briefly.
Kip Gehring with Zage Security, and one of the problems and challenges that we're working on is, I think, very applicable to smart cities. We talk about a multitude of different networks being deployed at a smart city depending on the use cases. Ideally, you would want one ubiquitous network that covers everything. I'm not sure that that's going to be a reality. But there's some key points that the panel brought up that have yet to be addressed, and that's with edge applications and applications talking to each other. The security needed associated with that at the application level, I think, still needs to be addressed. Yes, the network security is there, but as an application, how do I know that I can trust that application telling me to do something, regardless of how that's communicated to me? And I still think that that's a big challenge to be addressed. So just a comment.
Well, actually, I'd expand on that a little bit in that. So one of the things, being in the utility industry, it annoys the heck out of me that nothing talks to anything without a lot of work. I can use DNP or I can use 61850, but I mean, I walk in a room and I can connect my phone to the network that's there if I have the credentials. Why doesn't that exist in the energy space or in the smart city space? Well, it doesn't exist because of what you just brought up, the security model. So there's a fundamental flaw that if we're going to allow things to participate with each other, we need to solve the security from the standpoint that it is seamless, it happens, and it's trusted in some way that always works. And I don't believe that the current IT security models are it. It's a different model. I don't know what it is. I'm not a security expert, but I know that my iPhone is secure as heck. And that's the kind of security level we need, something that's trusted, that has probably a hardware component that's involved, as well as somebody who has the keys, or somebody's, maybe like a DNS name provider. I mean, we rely on those every day for the network to stay up. So maybe there's some similar aspect with respect to security that provides that fundamental capability. But it's very key to the electric utility industry being able to, or the gas or whatever, to be able to leverage devices behind the meter for benefit for all.
Oh, one more question. Yeah, Dick.
Hi, Dick Slonsky from ARC. Very interesting discussion. We've been down talking about the nuts and bolts to a certain extent here. I have more of an overarching question in terms of as we move into the urbanization of concentration, but then we have also these ecosystems of smaller cities, towns, municipalities. How are we going to address the participation in terms of all these other smaller entities in terms of their resources, in terms of their being able to use the technology and be able to do it and so forth? Are we going to, I'm just throwing this out for a question, are we going to move into an era of, say, a lot of large urban areas that are totally connected and smart and everything, and then have a lot of dark spots in between? Is there going to be a distribution issue? Are we going to have sort of in the terms of small town cities and municipalities, the haves and the have-nots, so to speak? And I'm just throwing this out. How do you see this in the future happening?
Frank?
Yeah. So in fact, we work with a lot of municipalities with all size. So I think one of our smallest customer has 15,000 inhabitants, and the biggest multi-million cities. I think technology can also solve this question. For example, we've made an agreement with Waze, so you know the traffic app, and they have an interesting program for all of the cities around the world. So as long as the city is okay to exchange data with Waze, Waze is okay to give for free traffic data, so real-time incidents, real-time traffic in the city. So that's also a way to have on board not only the big cities, because the big cities, there are infrastructures, smart cameras, and so on. And the movement we see since 1 or 2 years is also mid-sized cities, even small cities. They want to use this free data. Of course, it's linked to Waze, and Waze is Google, but at least everyone in the US, in Europe, is using Waze to move. So they use crowdsourced free data. And for example, our value proposal is also to come with a very easy-to-use platform that don't require any data scientists, don't require any IT team. And sometimes you can be more agile with some pre-packaged apps and platform than having a whole team of data scientists where outcomes could be longer. So I think even small cities, they are interested into that. And as you have new players like Waze, for example, maybe you don't really need to install sensors to count the traffic. Sometimes you can just rely on Waze, but at least it's better than nothing. It's free. So there is an interesting mix.
If I could comment, we have a lot of opportunities in smaller cities, and oftentimes they have a higher motivation. If you look at the cities around Boston, New Bedford, 100,000, Lowell, Worcester, as they say, they're all looking to become smart, and they're actually sometimes able to move a little bit faster. And I think it's incumbent upon us as technology providers. I mean, you saw how easy the Open Data Soft platform is to use. I mean, if we can develop tools and smartphone apps and have like folks develop to our Near Sky platform where they have apps that are easily to implement and can be shareable with citizens and city workers, I mean, I think you'll see a lot of stuff going on and a lot of initiatives in the smaller cities. Just to give you a real simple example, New Bedford, a town of 100,000, south coast of Massachusetts. It's a smart city, 10,000 LED plus streetlights. Highest concentration per capita of solar in Massachusetts. And they instrument their snow plows with temperature sensors, so they can go out and take street temperature measurements and know, okay, for this storm, looking at the weather and what the road temperature is, do I need to go out in sand and salt? And if I don't have to go out in sand and salt, I save $35,000 a storm per day. So they're doing a lot. They just don't get the visibility and the publicity that Atlanta and Austin and Columbus and Pittsburgh and all the other big guys get. But they're doing stuff.
Well, as a guy that grew up in Montana and have driven across and not had connectivity and didn't know where I was going, had to stop at the local general mercantile to get a direction, I think there is a clear potential for a problem. If you're in a small town, and I'm talking towns now, not cities, the more this technology gets adopted, the more advantages people will have that have access to it, because their connectivity and their ability to do things across the globe will be substantially better than somebody sitting in towns in Montana where there's not even a network. So it is a problem. There is opportunity. I think anybody that has streetlights, it's a really good way in for smaller towns, because they still have to go put bulbs in. And if they're using old technology, just the fact that the LEDs last longer should be a positive business case, which they can then get into the network. But it's really tough. I mean, we serve a lot of communities that don't even have digital records. If you want to go look at a plat map, you're going to go look at a plat map. It's not digital. And so I do worry about that. I think that there are going to be a number of communities that just disappear because of this divide that'll get created. So we have to, I think part of what we'd like to be able to do with Urban Nova is export the whole thing as a usable, if you will, kit, a template and a kit that you could do it for a very inexpensive approach. But still, it will come down to a lot of things that are outside of the control of the technology or the people. It'll come to what they can actually do with the records they have. And money.
Yeah, yeah.
Just one question from me. The Urban Nova initiative, what is the longer-term goal? What's your time frames, and what are you trying to achieve in terms of certain milestones?
So it really is a laboratory. So one of the things one of our primary goals is as an accelerator. So an accelerator, so we're very big into creation of companies or products or services that have value. And so one of our interests is it being an accelerator for technology, an accelerator for services, accelerator for companies that want to experiment there. So we would like to see in the not too distant future it become a hub for acceleration. And there's a number of things in the works that I can't really talk about at the moment. And then getting through the projects that we currently have. Now, any kind of a lab like that, I think your biggest challenge is who's funding the project that comes in, right? So we have to have interested parties that have money, that have an interest in testing something. And so I think the one challenge we have with people coming in and testing, it's not their people, it's not their municipality, maybe it's not their, so there's some differences in how you actually pull that off. So, I think we're trying to solve all the foundational problems really, really well and branch from there. And so the projects we have are obviously the ones I talked about, and we have strong interest from partners. We're open to anything. We'll continue to advance the platform. That's really important. Perfect the foundation, and then just accept any other things that come in. So I can't tell you that we have a specific goal for. I have goals, and I could tell you what those are, but they probably don't. The Urban Nova folks will go, what? Because I have pretty lofty goals: a complete peer-to-peer transactive network, which is a retail market, and some stuff like that. But that's not an official Urban Nova goal at the moment.
Yeah, I think, we've talked a lot about technology, and obviously it's important to be able to enable smart cities, but I think an equally important element is what is the new collaborative business model and teamings that will exist between utilities, cities, technology providers, and then the energy services companies that often deploy these. And if you look at, for example, the Department of Transportation Smart City Challenge, 78 applicants, 7 finalists, Columbus won. Just go look at some of the proposals and look at the associations of companies that work together on those applications. Everyone was different. And as an example, I know San Francisco, when they were submitting their final proposal as one of the 7 semifinalists, they had pledged services and hardware, software in kind from prospective business partners, if they won, in excess of $120 million. So, it's a new ball game, and we've worked collaboratively with GE in a few places. We compete against them. GE's got something that's pretty strong with AT&T and Georgia Power. So every deal is going to be different, and the cities will find their own way to put together the right consortium to ensure a path forward.
Let me just add, because you were talking timelines. So the projects that we have so we're adding additional street lights with sensors and additional connected street lights. So not all of them are in place, but they'll be in place the first half of this year. So that project will essentially be complete with the research taking place with Washington State University on the air quality. And there's a bunch of research going on. If you go to the website, you can see a list of, 13 or 14 projects that they have around air quality types of things that they're leveraging the data for. The shared energy economy model, that is designed and being built this summer. So that will be complete by the end of the year and start doing all of our testing around the energy services model and how we transition from a tariff to and how we optimize in that. So we'll be running that for another year after that to evaluate, and then that'll be complete. The final one, that Catalyst building, the plan is to have that done and built by the end of 2019. So those are the tangible things with respect to the projects that were in place.
Excellent, thank you.
Okay.
That's it.
Well, I think we're at the end. I want to thank our presenters and panelists here. Let's give them all a big round of applause.